Okay, now this section we're going to get into acids and bases. So I'm going to kind of try to give you a quick explanation on each of the three different naming systems. The first is going to be Arrhenius. So Arrhenius is all about hydrogen ions or hydroxide ions. So if you look at the examples here of an acid, we have hydrochloric acid mixing with water, and that creates a hydrogen ion and a chloride ion. Another way of seeing this is that HCl plus water ends up making a hydronium ion and a chloride ion. So it's not that hydrogen ions are just floating around in solution. What they're doing is they're joining up with the water to make H3O plus, and then your negative ion. So hydrochloric acid is a hydrogen ion producer. Sodium hydroxide is a base. When you mix it in water, we have the sodium ion and the hydroxide ion being produced. So in the end, for Arrhenius, hydrogen ion, hydroxide ion. That's how we're defining acid and base. Now, we're going to get into the next section, but the same idea is holding true, that an acid is an acid is an acid. So if it's an acid by one naming system, it's an acid by another. So here, we're going to talk about Bronsted-Lowry. Get my head out of the way. Bronsted-Lowry. So Bronsted-Lowry says that acids and bases are determined by what happens with the hydrogen ion. Acids produce a hydrogen ion. Bases are hydrogen ion acceptors. Hydrochloric acid, so a similar example from before. Hydrochloric acid donates or produces its hydrogen ion. And this is a better example of what's actually going on, is that water attracts the hydrogen ion. So the hydrogen ion is going to go onto water, making water now H3O plus. Well, according to this, a hydrogen ion acceptor, water gains a hydrogen ion. What does that make water in this case? It makes water the base, HCl, because it donates the hydrogen ion. HCl is the acid. So an acid, HCl is an acid by Arrhenius, by Bronsted-Lowry, by all of them. Now base, ammonia, NH3. This is a different type of base than what we described in Arrhenius. The lone pair of electrons attracts the hydrogen of the water molecule. Because water is partially positive on the hydrogen, partially negative on the oxygen, because oxygen is more electronegative. Now, we had a really long discussion in class about what's going on here. To kind of give a brief synopsis of that conversation, we talked about the electron placement, and to kind of just show you a better diagram of what's going on here. So we can kind of look at this, right? So we have electrons being shared. I don't know why I put two sets there. Electrons are being shared between nitrogen and this hydrogen, nitrogen and this hydrogen, and here and here. And then here we have a lone pair. Well, the hydrogen-oxygen bond is polar. The electrons are favoring the oxygen. Well, that means that this is what's going on in the hydrogen-oxygen bond. When the electrons are between the two nuclei, the nuclei are attracted to the area between the two nuclei because of the negative charge of the electrons. But through random distribution, this is the oxygen here, oxygen, hydrogen, those negative electrons are occasionally going to be more around the oxygen than around the hydrogen. Well, because hydrogen has no other electrons around it, it's going to end up being very positive. And now there's no force of attraction between the hydrogen and the oxygen. Well, this is the case where the lone pair on the nitrogen, ends up attracting that hydrogen nucleus that doesn't now have a very strong bond with the oxygen. So that's how nitrogen is able to take the hydrogen, well, I said take the hydrogen from oxygen. So here, if we look at it, water is donating the hydrogen to the NH3. So here, water's the acid. And then NH3 becomes NH4 positive. So NH3 gained, it accepted a hydrogen ion. So here, NH3 is the base. So Bronsted-Lowry, it's all about what's going on with the hydrogen ion. Last little bit, we're going to finish up in hopefully 42 seconds. The last one is Lewis. And Lewis describes an acid and a base by what's going on with the electrons. So Lewis acids accept electrons. Lewis bases donate electrons. So we're going to look at basically the opposite of what's going on with Bronsted-Lowry. Here, water donates a lone pair of electrons to take the hydrogen from the HCl. The bonded electrons now go on to the chlorine. So oxygen is donating a pair of electrons. That makes water the base. It used a pair of electrons. Hydrochloric acid is a hydrogen ion. The hydrogen accepted the electrons. So HCl is one compound until the hydrogen accepts those electrons from water, donating the rest of the electrons to chlorine to make chlorine negative, and then we get our H3O plus ion again. That was pretty much as quick of a job as I could have done with the three different types of acids. I hope this makes sense. Come to class with some questions if you have any. All right, nice work.